Hello class. I thought I would do one more example for you. Hopefully this will help you to do your assignment. There's been a question raised about how you submit a graph through Moodle. And I'm still investigating MathType to see if there's some way we can do it there, but as of right now, the method will be to do your graph on a graph paper, something like this. Take a picture of it with your cell phone, and then you can either connect your phone to your computer and move the picture to your computer that way, or probably the easiest way is just email the picture to yourself. So email that photo to yourself and then go to your computer, open your email, download the picture, save it on your hard drive someplace, and then when you go back to Moodle and you open up your assignment, you go to the question that requires the graph, and in that question there's a place for uploading a file, and there you can upload the picture of the graph, and I will have that in connection with your answer to that particular problem. Okay, let's go ahead and get started on this problem here, this example. I'm going to try to do everything we can with this. We'll thoroughly investigate this equation, or this function. F of x equals minus 2x squared minus 8x minus 5. Notice that a is negative 2, b is negative 8, and c is negative 5. This is in standard form. A, b, and c are as indicated, negative 2, negative 8, negative 5. The first thing we'll do, which is generally a pretty good thing to start off with, is to see if we can't find the axis of symmetry. And you know the equation for axis of symmetry is minus b divided by 2a. So we put in our b value right here, negative 8. We put in 2 times a, 2 times negative 2, and of course the minus sign out front. So a negative divided by a negative is a positive, and then we put a negative in front of that again. So our answer is going to be 8 divided by 2, or 8 divided by 4 rather, which is 2, and then the minus in front, so it's minus 2. Okay, so that tells us that the line of symmetry, or the axis of symmetry, is negative 2. So we take our ruler, and we come over here, take a ruler, come over here to the graph, and we will proceed to put in a line indicating negative 2. And I'm going to make it a dashed line, and the reason it's dashed is because it's actually not part of the graph. It's just a guide to assist us. So we go ahead and put our dashed red line in here. And this is indicating our line of symmetry, like that. And notice the scale that I picked. There's actually 10 little divisions in this graph, but each of the heavy lines I decided to make 2. So 2, 4, 6, 2, 4, 6 this way, negative 2, negative 4, negative 6, and likewise going down. So now that I know the value of my, or the equation for my axis of symmetry, I know that no matter where I go on this line, x is always negative 2. So what is my vertex? That's the question. Well, the vertex will fall on this line because the graph is symmetrical. By the way, it's opening downward because it's negative. A is negative, so it opens downward. And at any point, I can take two points from either side of this graph. The axis of symmetry is right in the middle. So as I come up, assuming I come up here, when I get to the vertex must fall on the line of symmetry, or the axis of symmetry. So that means that the vertex has an x-coordinate of negative 2. So we can go ahead and we can put that in right here. We can say the x-coordinate of our vertex is negative 2. What will be the y-coordinate? Well, the y-coordinate is the value of the function at negative 2. So as you come up the graph, bringing x backwards, you come up the graph until you reach the vertex. If you put in negative 2 for x into this function, you will find the y-coordinate of the vertex. Negative 2 times negative 2 squared minus 8 times negative 2 minus 5. Well, negative 2 squared is positive 4. Positive 4 times 2 is 8, but then there's the minus sign in front, so it's minus 8. And then subtract 8 times negative 2, you're subtracting negative 16, which means you're adding 16, then minus 5. So negative 8 plus 16 is positive 8, subtract 5 is positive 3. So we know now that our vertex has a y-coordinate of positive 3, okay? So there's my vertex, negative 2, 3. So negative 2, 1, 2, 3. So 3 is like halfway between. So let me count my marks. 1, 2, 3, 4, 5. Right here. That's my vertex right there on that red dot. Now I need some other points in order to find the equation of this graph. The next one that's very easy to find is the y-intercept. The y-intercept is extremely easy to find. And we'll do that. But first of all, let me make myself a little table of x and y so that hopefully we can keep track of everything here. So we make ourselves a little table of values of x and corresponding values of y. So if you like, x and f of x. So we just found the vertex, and that was f of negative 2. So if you put in negative 2 for x, what did we get out? Negative 2 into the function, we got out 3. Okay. How about the y-intercept? Well, the y-intercept is an interesting point. If this is a vertex, imagine the graph is falling. Okay, it's falling. As we move to the right on the x-axis, we're going down on this line. The y-intercept occurs where the graph crosses the y-axis. Where does the graph cross the axis? At what point? Well, we don't know the vertical displacement yet, but we do know the x value where it crosses. Any place when a graph crosses the y-axis, the value of x is always 0. So we know initially here that we can put 0 right here. And if I put in 0, we will get out what? Try f of 0. We don't have to work this one out, we can just look. If you put 0 for x, there'll be a 0 term here. 0 for x here, this would be another 0 term, so we'll just end up with the last term, the constant, negative 5. So we know that 0, negative 5 is our y-intercept. And we can write that down right here. We can put 0, negative 5. That's my y-intercept. Where is 0, negative 5? Well, way down here. 1, 2, 3, 4, 5, right here. Okay? Notice that 0 on the x-axis is 2 units to the right of the axis of symmetry. See, this is 2 units. Negative 2, negative 1, 0. So 2 units to the right. If we go 2 units to the left, we will find the symmetrical point on the other side. 1, 2, 3, 4, 5. Right here. So that's my point on the other side. And that is what? Negative 2, negative 4, right? Negative 4, is that correct? Should be. So 0, negative 5. Negative 4 should also be negative 5. So we can put that in there if you want. Negative 4, negative 5. Okay, again, either side of the axis of symmetry. Now this is rather a long distance between this point and this point. So it'd be nice if we had another point someplace to kind of give us a little more accuracy in our graph. It'd be hard to draw an accurate graph with only 2 points. So it'd be nice to have one somewhere up here in the middle. What about if we put in x equal to minus 1? What would we get out if we put in x equal to minus 1? Well, let's try that. Let's try f. I'll use black for this. We'll use f of minus 1. What will we get? Well, it's going to be negative 2 times negative 1 squared minus 8 times negative 1 minus 5. So negative 1 squared is positive 1 times 2 is 2 with a minus sign in front. So this is negative 2, and then minus a minus means plus, so plus 8. which is 6. Take away 5 is 1. So we should get out 1. Again, negative 1 squared is positive 1 times 2, or times a negative 2 is negative 2, and then plus 8 is 6, and then 6 take away 5 is 1. That's equal to 1. F of negative 1 equals 1. And then likewise, negative 1 is 1 unit to the right. Negative 3 would be 1 unit to the left. So if I could go ahead and put a negative 3 in here, I know that I would get the same thing, 1, because it's symmetrical. So negative 1 and 1. So let me count here. 1, 2, 3, 4, 5. Should be right about there. Okay, and then on the other side, 1, 2, 3, 4, 5, right about there. Okay, so there's 2 points. You know, perhaps I could do one more somewhere in the middle here, and that would be, instead of negative 1, maybe negative 1/2. What would I get if I put in negative 1/2? I'll put it up here since I'm running out of space below. Negative 1/2. What would I get out if I put negative 1/2? Okay. What is f of negative 1/2? It'll be equal to negative 2 times negative 1/2 squared minus 8 times negative 1/2 minus 5. And so negative 1/2 squared is positive 1/4. 2 goes into 4 2 times. And so this is negative 1/2. Okay, plus half of 8 is 4. And then take away 5. Well, 4 take away 5 is negative 1, but then subtract another half. So this is equal to negative 1.5. Okay, negative 1.5. Okay, negative 1.5. Well, let's see if we can do this. 1/4 is 1, 2.5 here. Negative, what do we say? Negative 1.5, right? Okay, so this negative 2, negative 1.5 is going to be just up here at 2.5 marks. It's a little tricky to graph because of how small they are. 1, 2.5, 1, 2.5. It's about right here. Okay, I might be off a teensy bit, but roughly right there. And by the same token, if I come over here, 1, 2.5, 1, 2.5, right about there. Okay, then I try to sketch my graph. Now on the graph, this is called an inflection point. That means that it's changing from going up to going down. And really right on the dot, it's basically a flat surface. So we need to have a smooth corner here. It's kind of tricky to do, but you know, you do the best you can. Kind of like that. I'm going to turn the paper so I can do this a little smoother. Okay, so we need to go over the top. Kind of like that. Okay, so there's my graph. Now, what other 2 things can we answer about this particular problem? Well, first off, we need to identify, is this a maximum or a minimum, the vertex? It is a maximum, so we write maximum. And what is the maximum value of this maximum? Well, the coordinates are negative 2, 3. So the maximum value is the y-coordinate. It's how far up you shift. So it's 3 units up. 3 units up. And yeah, so the maximum is 3. And what's the domain and what's the range? Well, the domain, what can you put in for x? You can go as far to the right as you want on the x-axis or as far to the left. So it's all real numbers. And what about the range? Range is a set of y. It's what we get out of the function y such that y, what are the possible values for y now? Well, this is a maximum. Can y equal to 3? Yes, it can. Can it be anything greater than 3? No. Can it be things that are less than 3? Sure can. How many numbers less than 3? This graph goes down infinitely far in both directions, on the right side of the axis of symmetry or on the left. So the range is y such that y is less than or equal to the maximum value of 3. Okay? So I believe that should do it for us. We've identified, first off, our axis of symmetry was the line x equal -2 by using our formula minus b over 2a. Please memorize this formula, x equals minus b over 2a. Then we use the value of x for the axis of symmetry right here. We use that value of x, -2, plugged it into the function to see when you are on the line of symmetry, what will be the value of the function. The value of the function will be 3. So we put in -2 and we got out 3. That identified the vertex as -2, 3. Then the next thing we did, we said, well, what's the y-intercept? That's always an easy one to find because you just put 0 for x. We put 0 for x, this term 0, this term 0, and we just have the -5. Subtracting 5 there from 0 is -5. So we got 0, -5, 0, -5. But we know the graph is symmetrical, so therefore on this side we also have a -5 when we go 2 units to the left of the line of symmetry. Just like we went 2 units to the right, we got -5, go 2 units to the left, you also get -5. So we were able to put in -4 and -5. Okay? Then the next thing we did, we said, well, that's not enough points. We need another point. Let's take, how about -1? And we stuck in -1, and we found out we got +1. -1, +1. Or -3, also +1. And then we said, well, it'd be nice to even have one more point. So that's why we chose the -1/2, and we got -1.5. And, that helped us a little bit there to get this additional point here, which was nice to give us a more smooth curve. And then, of course, our domain and our range and our maximum of 3. I think that pretty well sums it up. I hope this example helped you. If you have any questions, you can WhatsApp me or use the text feature within Moodle. You will not receive an extension on this exercise that you're currently working on. It's due Monday night. You need to get it done. I will be putting up a lecture tomorrow dealing with section 9-2, the next section in dealing with parabolic functions and equations. And we need to just keep moving forward with this. I think, though, once you understand this section right here, if you can work through this problem and understand it, you're in pretty good shape. I don't think you have too much problem with the rest of this chapter. All right, blessings to you guys. Study hard, be diligent, and don't slack at all. Work every single day. Don't let a day go by without working. And we hope that we'll make good progress. Okay, I'll watch for questions if you have any.